let's unlock a powerful feature in Spring Boot 3.2, the HTTP interfaces. If you've been dealing with the REST template or the web client, you'll love this simpler, more declarative approach. And by the end of this video, you'll know how to use the HTTP interfaces to call external APIs, and we'll also test our implementation using integration tests. So let's jump in. To keep things simple, we will use a free mock API from JSONPlaceholder. We would look at the to-dos endpoint in order to fetch, create, and update to-dos or tasks. So to get started, we'll just copy the JSONPlaceholder base URL and use a test line tool like Postman just to study the API before coding it. As you can see on the left-hand side here, I've got 4 API operations to work with. The first one I'll perform is the fetch all to-dos. And as you can see, we got a good response code 200 OK and a list here at the bottom of all the tasks. The nice thing about doing this is that we also get to study the data structure. Second, we can perform an operation where we fetch a to-do by an ID. When fetching a single record by an ID, you get a clearer picture of the data structure. So we've got a user ID, which tells us who owns the task. Number 2, we've got an ID, which is a unique task identifier. We've got title, which is the task description. And the last one is completed. It's a status telling us whether the task is done or not. The next operation we'll perform here is the HTTP post, so that we can create a new task record. According to HTTP standards, you'll need a body in order to create or post a new record. You'll also notice we do not have an ID because that's only generated after being created. So notice after my call, I got a 201 created HTTP status code, and I've also got my record with an ID property. The last one in this case is similar to post, but in this case is a put. According to the HTTP protocol, the put is there for us to update records. So in this case, I'm just going to run a quick update, and there we go, another successful response code. So all in all, doing this in an HTTP REST client testing tool, we get to have an idea of how the API behaves and the data structure that we'll be working with. In other words, the JSON structure. This means now we're ready to integrate via code. Let's get started. Okay, so I've got a project here, and the main dependency you need is the standard Spring Boot starter web. Nothing fancy. So I would like to start by creating a data class that represents our JSON structure that we learned earlier. So to get started with our to-do class, I'll create a package just to organize code neatly. We'll call this class to-do, and it's a data class, a Kotlin data class in this case. For Java, you can leverage Lombok or use the Java records. So at this point, you need to recall or remember the JSON structure. So first we had an ID, and this ID is nullable because remember, we only get the ID after we have created a record. The second one will be user, and for user, we can make this a non-nullable field. The next one will be the title. The title is a string type. And the last one we need is a boolean telling us if this has been completed or not. And I'm going to leave this completed field with the default status of false, because when you create a new record, it cannot immediately be completed. And that's it. The second component we need is the actual interface. And for that, I'll create a new package named client. And in there, I'll create a new interface. And this new interface will be named to-do client. So in our to-do client, what we need to do is first tell Spring that this is an HTTP interface. The next thing to do is to implement the methods. These methods are the ones that correspond to an API endpoint for operations like the get that we saw, the post that we saw, and the put that we saw. So we'll start with the fetch all, which fetches a whole list of to-dos from the API. And this will return a list of to-dos. Now we have to tell Spring that this method will correspond to the get HTTP operation for the to-do list. So it's as simple as that. So after adding this single operation, you get the concept, you get the idea of what we're doing here. So what I'm going to do is speed up the process by adding the rest of the operations. Okay, so here we are. We've got the rest of the operations. We've got the find to do by ID. We've got the post of a new to-do record. And we've got the update of an existing to-do record. This now completes our interface. And Spring is actually powerful with this interface because what it will actually do is automatically generate an implementation of this interface for us. But before that, we just need to add the third of the 3 components that are critical for this task. And this component will help us tell Spring Boot how to instantiate our to-do client. We do this with a factory configuration. So for that, I'll create a standard Spring configuration class, which I call an application factory, because the factory of beans. This factory will be a standard Spring configuration class. And in this class, we need to declare the bean. This bean will be the factory configuration for our to-do interface. So we'll name this bean to-do client, which of course returns a to-do client instance. And remember, this will be a Spring managed bean. So in this bean, we will instantiate our to-do client as follows. The first thing is we need to ask Spring to inject its own object, the REST template builder. And we're going to use this REST template builder to configure our base URL. So for that, we'll just have a constant here. And the constant will point to the JSONPlaceholder base URL. And with that, we're just gonna build, pop that into a variable. Next, we'll wrap that into an adapter and pop that too into a variable. And now for our HTTP factory configuration, now we can finally return the final result. And that's it for configuring our to-do client REST template. At this point, we are done with the implementation. Now we need to validate if this works. And for that, we're going to create an integration test using our to-do client interface. So I'm quickly going to create a test class. Nothing new here. We're just creating a Spring Boot test. And in our test, we want to inject the component that we're going to be testing. So we declared the test as a Spring test. And we're injecting our to-do client, which is the interface that we want to test. And since we're using Kotlin, this is just Kotlin's way of doing constructor-based injection. Now we create a new test case. We will say this test case should fetch all to-dos. Okay, so what do we want to do in our test? First, we want to fetch all the to-dos. And on that note, we also want to assert true on the fact that it is not empty. And if it is empty, we'll have an error message in there. So we can say tasks should not be empty. And maybe at the same time, we want to print out stuff. So we'll bring in the Kotlin logger, which is also based on SLF4J. And we can say, and after fetching information, we can just log something. Instead, we can say found a total amount of tasks. So the total amount will come from it size. Same as Groovy language, if you do not name the variable inside your Lambda, it will resort to it. For clarity, what we can do is tasks, and now we have a variable in our Lambda, and then we can reference that there. Now this makes more sense. So this is our test case. Let's give it a go. Okay, cool. So our test case has passed, and you can also see some of the printouts that we wanted. Okay, so that's it. You get the concept. What I'm going to do is speed up the process again by adding more test cases, and then we can go through them quickly. Okay, so I'm done with the test cases. We can go through them quickly. So the second test case is this one here, and we're testing if we can find a record by its ID. Nothing fancy. We know that the status on the server is actually false, so that's why we're validating that and doing a quick printout. The third test case is for our post, where we create a new to-do record, and we also validate that our ID is null for obvious reasons. Now finally we do a post, and on that post we also validate that now we have an ID, which means we have created a record successfully. The last test case is a little bit more involved, but then again, the idea is to find a record by ID, validate information from the server, then we change some information, and finally we call the update operation and also validate that the information has indeed been updated. And that's it. Let's have a quick recap. What you need is a DTO or a data class, basically representing the information that comes from the server. The second thing is you have your interface with the operations or the methods that correspond to the API endpoint. The last thing is you tell Spring how to instantiate a REST client using your interface, which is critical because that's where you also set the base URL or the target URL of the service. After that, you're done. You can use your interface, and if you would like, also just quickly test it. And that's it. With just a few lines of code, we've built a fully functional HTTP client using Spring Boot 3.2's REST client interfaces. And this approach simplifies API calls, reduces boilerplate, and integrates seamlessly into Spring Boot applications. If you enjoyed this video, then like, follow, share, and subscribe for more content like this. I will see you in the next video.